wrong. And what's that probability for 0.88? Good. No, we're going 3 decimal places and we're rounding. Some of you are not good at rounding. Okay, 4 correct. How many ways to have 4 correct? Same as 1 correct. There are 5 ways. So this is 5, and I got 4 of them correct and 1 of them incorrect. So my probability of getting 4 correct? 0.015 with rounding. Probability of getting all 5 correct, which would mean I got to correct. There's only one way to do that. Oh, sorry. Jeez. There we go. And that is 0.25 to the 5th, which is, somebody tell me what their calculator says, and then let's make sure we can read this. 9.77 times 10 to the negative 4. That means a decimal, 3 zeros, and then the 977. Okay? So what do I round this to for 3 decimal places? 0, 0, 1. Okay? Okay. We can all round. Some of us can, some of us can't. Okay. All right, so let's make a distribution for this. So this is for the number correct. And the probability, 0, 1, 2, 3, 4, 5. 0 was 0.237. 1 was 0.396. 2 was 0.264. 3 was 0.088, 0.015, and 0.001. So we saw in our simulation that getting 1 correct came up most frequently, and yes, the probability of getting 1 correct is the highest. Okay? Now, here's where we get into the whole binomial deal. Okay. If I got to meet 4 criteria. Criteria number 1, you have outcomes that are binary. What do I mean by binary outcomes? Your outcome could be right or wrong. Your outcomes could be true or false. Your outcomes could be male or female. That's 2. That's binary. You can't have yes, no, and maybe for your outcomes. Okay? You can only have 2 choices for your outcomes. So if you have binary outcomes, if your observations are independent. This independence is important. What you answered for problem number 1 didn't affect how you answered problem number 2, etc. And the person sitting next to you was not influencing your scores on your Swahili exam. So we need some independence from question to question. And if the probability of success is always the same, and our probability for success was 25%, it never changed. Okay. If I meet these 3 criteria, these are Bernoulli trials. The 4th criteria puts me to a binomial. Bernoulli is used in a lot of parts of mathematics. Yes. But especially with probability. So if I add this fourth criteria, which is called a fixed number of trials, so trials or observations so what do I mean? A fixed number of questions. There were 5 questions. Or I ask, I may have another kind of survey, and I ask a fixed number of people, 100 people. If I know the number of questions or I know the number of people that I ask, then this is a fixed number of trials. If you have all 4 of those things, you're in a binomial setting. If you meet all those, you don't have to write down every single way you could get C's and W's. You can use the formula for a binomial. Okay? So if I'm in a binomial setting and I want to figure out probabilities, I need to know 2 things. First, I need to know the probability of success, and we call that little p. And I need to know the number of trials, and we call that number n. And if I want to find out the probability of k successes, and officially we would probably write that as the probability that x equals k. So the probability of getting 1 question right, or the probability of getting 5 questions right, probability that my random variable is equal to 1 or 2 or 5 or whatever number you want to put. Then by formula, that is, come on, I can get there. There we go. So that probability is n choose k. We'll go over that formula in a minute. I didn't have time to get to it last period. N choose k times the probability of success. So in that case was 0.25 times the number to the power of the number of successes I want to the k. Probability of failure is the complement. So that's 1 minus p. And as Brian pointed out, there was the exponents always added up to 5. They always add up to n. So that exponent on this one we write as n minus k. And that way when you add them together, they'll be... k is the number of successes. Yes, ma'am? Oh, so this is a way of writing a number. Let me define this number. It's not a fraction. N choose k, no fraction sign, just parentheses, is n factorial divided by k factorial times n minus k factorial. That's the formula you learned in Algebra 4. This is the number of combinations the number of combinations of size k from a set size n. For those of you who don't like dealing with these ugly mathematical formulas, in your calculator you would type in the n, and then you would hit the math key. Then you would arrow over to probability. And then I'll show you what n is in just a minute. And then it would be, I can't remember what number it is. I think it's number 4? NCR? 3. It's number 3, and it's the NCR key. And then you would hit the K, and then you would hit the enter. Okay? So